Hello, my name is Mengyang. Along with Weichen and Yanbo Zhang, we will present you with our final report of our NLP project, a question asking and answering machine. This is an overview of our presentation. First of all, we introduced correct resolution into our model since it largely boosts performance of both parts of our QA machine. For consecutive sentences in real text, nouns are usually replaced with pronouns for simplicity. However, such replacement commonly equates ambiguity in nouns and entities and makes sentences dependent on each other. To eliminate such ambiguity, as well as making sentences independent, we use neural correct from spaCy to replace pronouns to its corresponding noun chunks from dependent sentences. For instance, by changing it to a banana in this case, we can generate more reasonable problems.
So here comes our pipeline for question generation. First, we did some common pre-processing on the raw text by using spaCy. Then we use these NER tags and dependencies to extract some important information and apply them with tokens to generate two types of question. To be more specific, as the question formula shows, we split the generated question into three parts: question words, related verbs, and rest tokens. Then we filled prior extracted information into these parts. Take the following sentence as an example. First, we located the named entity and their tags in this sentence, which is Andy with the tag as person. Then we could decide what WH question we could ask and assign question words to it. In this case, we assigned who. Now it comes to the related verbs. We apply the dependencies and focused on the cases when dependency is n-subject or n-subject path, since in this case, mostly the dependent in the dependency is what we call related verbs. The innovation in this part is that instead of parse tree, we use dependencies to fill out the question formula. Doing this could give us more grammatically correct questions without losing original information from the rest of the sentence. In this sentence, Andy is a nominal subject of the verb ate, so we could determine the related verb for WH question is ate and for yes-no question is did. The rest of the sentence would simply be put into the rest tokens part. Then the two types of question would be generated as shown. Here is a special example when dependency is n-subject passive. We still follow the question formula, although we process the original sentence a little bit differently. After we could generate questions from raw text, another thing we need to do is to evaluate these questions and select the more meaningful ones. One innovation we attempt here is to assign weights to WH words as well as yes-no questions. And we figure out that those questions started with who, when, or where are more meaningful than those started with what or why, since the answers for latter types of questions would be more ambiguous. However, after we built this kind of evaluation, we found that different articles have different distribution of NER text, which led to WH words. In these cases, the so-called meaningless questions started with what or why would have higher rankings, or even that one article would generate only one type of WH questions. Therefore, we chose to generate all possible questions from one article, save them into one list, and randomly select n questions from them.
For the answerer, we first applied a similar parsing process to question input and extract the key dependencies which indicates what the question is most concerned about. Then we searched for the sentences that are most likely to contain the information we want and look for the information we wanted from the sentences retrieved. To retrieve the most relevant sentences, we've extracted all the keywords from the question by removing all stop words. Then ranked the sentences in the order of number of keywords contained. We will try to answer the question with the sentence with most matches. If there is no answer generated by that sentence, we can try the next one until we got an answer or we used up all sentences in the top end list. This innovative sentence retrieval method allows us to only parse one sentence at a time and stop immediately when we get an answer, rather than parsing all sentences. This helps to improve the computing efficiencies of our system. In our final system, we use n equals 3. Here is an example to show the process to answer a yes or no question. Given a question and a retrieved sentence from the original article. The system will first parse the question and stores the key dependencies based on dependency type. For example, if the system gets this question, did Andy eat an apple yesterday? The root word is eat, and it would store key dependencies which give information like Andy eat, apple was eaten, and it happens yesterday. Then we check if the sentence contains these dependencies and if they are the same as the key dependencies from the question. In this example, since the object which was eaten is banana rather than apple as given by the original text, the system will give an answer of no. For WH questions, after we pass the question, we look up the WH word in the dependencies and see what it refers to. In this example, the WH word who is referred to as the thing that eats the banana. Then we search the dependencies from the original text and search for what eats the banana, which turns out to be Andy. Finally, the system would check if the post tag of Andy matches the WH word who. In this example, Andy has a proper noun tag and is a match with the WH word who. So Andy is a legitimate answer to this question. If the system could not generate an answer from any of the top n relevant sentences, it would give an answer of no answer.
For this project, we encountered a lot of unexpected issues during the development phase. For example, the migration from central core NLP to Spacey. Though we developed with core NLP in early stage, since somehow Docker doesn't work with it, we are forced to migrate our whole project onto Spacey. This involves complete modification of codes and a lot of time wasted. As a result, some parts of the final model do not perform well, such as the yes or no question generation part. We learn from these issues and will identify potential technical problems more clearly in the future, with the more appropriate schedule in our next project. Lastly, below are the tools and references we use for our project. Thanks for watching.